CNC machining promises perfection, right? You take a perfect digital model and it should spit out a perfect physical part every single time. So why are we still pulling parts off multi-million-dollar machines that are headed straight for the scrap bin? Well, that's the CNC Precision Paradox, and we're going to break it down today. On one hand, you have the promise, that beautiful, pristine component, exactly to spec, just like the CAD model. But on the other hand, you've got the painful reality, a failed part covered in defects that just scream wasted time, wasted material, and wasted money. This gap between the promise and reality, that's what holds so many shops back. So where does it all go wrong? I mean, you've got a top-of-the-line machine, your program is solid, you've got the right material. So what's the hidden culprit that's turning a great setup into a bad part? Well, it almost always boils down to 3 critical mistakes. And it all begins with mistake number 1, the shaky start. This is all about the foundation of your entire operation, your work holding. Because before you even cut a single chip, this is the moment. This is where precision is either locked in trite or it's lost forever. A shaky start creates a massive domino effect. If that workpiece isn't held with absolute, unshakable rigidity, you're not just looking at one problem, you're inviting a whole cascade of failures. Just think about it. Misaligned parts, awful surface finishes from all that vibration, and yeah, even broken tools. It all just piles up into wasted material and killer delays. Okay, so this lays it out perfectly. A direct line from the problem to the solution. Getting inaccurate parts, 9 times out of 10, it's inconsistent clamping. A self-centering vise solves that. That terrible surface finish from vibration, modular fixtures give you the rock-solid support you need. Even slow setups, which are a huge productivity killer, can be totally transformed by quick-change pallet systems. The big takeaway here is that modern work holding isn't just an accessory. It's the direct answer to these fundamental problems. All right, let's move on to mistake number 2, the imperfect cut. Because here's the thing, even with perfect work holding, the battle for precision is far from over. The second that tool makes contact with the material, a whole new set of challenges pops up. And the number 1 enemy here is chatter. An experienced machinist can hear it from a mile away, that high-pitched squeal of vibration bouncing between the tool and the workpiece. It leaves behind that unmistakable wavy pattern, completely wrecking your surface finish and just hammering your tools into an early grave. So how do you fight it? This is your battle plan. First, maximize rigidity. Use the shortest, stubbiest tool you possibly can. Second, optimize your actual tooling. Variable pitch end mills, they are literally designed to break up the harmonic vibrations that cause chatter. Third, play with your parameters. Sometimes a tiny 5% tweak to the spindle speed can hit a sweet spot. And finally, use the smart toolpaths in your CAM software that maintain constant tool engagement. This quote just hits the nail on the head. Toolware is so much more than just swapping out a dull end mill. It's a hidden cost center that is quietly bleeding your profits through lower precision, extra load on your machine, and totally unexpected downtime. You know, your parts will actually tell you when a tool is getting worn out long before it breaks. If that beautiful mirror-like finish suddenly goes dull, that's a dead giveaway for flank wear. Or if your parts suddenly start measuring just a little bit undersized, it means the tool's cutting edge has worn down, changing its effective size. These aren't random fluke events. They are clear signals your process is sending you. So what's killing your tools before their time? It's usually one of these 4 culprits. Running way too fast and generating a ton of heat. Using the wrong tool material for the job. That's a classic recipe for disaster. Cutting without good coolant is like running an engine with no oil. And hey, look at that last point, poor fixturing. See how it all circles right back to that shaky start we were just talking about? Okay, let's dive into our final mistake, number 3, the rough finish. This is all about that one step that is so often rushed or just treated like an afterthought, deburring. But let me tell you, this final stage is every bit as critical for quality as all the others. And here's why this is such a big deal. A poorly deburred part isn't just ugly, it's a liability. Those tiny sharp burrs can stop parts from fitting together correctly, they can create friction and wear inside moving assemblies, and they can even be a serious safety hazard for anyone who has to handle them. Relying on manual deburring is a huge pitfall. It creates massive inconsistency from one part to the next. But going too far the other way, over deburring, is just as bad. You could end up ruining critical functional edges. The real solution is to stop treating deburring like some last-minute cleanup job and start treating it like what it is, an integrated, controllable part of the manufacturing process itself. So, after all that, we finally arrive at the final inspection. This is it, the moment of truth. This is where all the previous steps, the work holding, the cutting, the finishing, it all comes together for one simple verdict: pass or fail.
When a part fails inspection, it's usually out of tolerance, the surface finish is bad, or its geometry is all wrong. But here's the absolute most important thing to get. These are not new problems. They are the symptoms of the mistakes we've just been talking about. A dimensional error, that points right back to bad work holding or a worn-out tool. A nasty surface finish, that screams chatter or sloppy deburring.
Okay, so we've diagnosed all the problems. Now let's put it all together. This is your path to perfection. Think of it as a toolkit for mastering the entire process, from start to finish. This chart really synthesizes everything we've covered, doesn't it? Unstable work holding at the framation? You solve that with modern fixtures. Chatter and tool wear during the cut? You beat that by boosting rigidity and optimizing your parameters. And inconsistent finishing? That gets fixed with automated, controlled processes. When you approach it like this, inspection stops being this dreaded final judgment and becomes what it's supposed to be, just a simple confirmation that you did the job right. So the next time a part fails, don't just see it as a setback. See it as a data point. Every single failure is a clue. It's a piece of information that is telling you exactly where your process needs to get stronger, more reliable, and more repeatable. And that brings us to the final question. And this one is for you. After seeing this whole chain reaction, from a shaky start all the way to a failed inspection, which one of these mistakes are you going to focus on eliminating first in your own shop? Because the path to perfection starts by fixing one thing at a time.